Question 1 shows that magnesium is more electropositive than copper, so magnesium is the negative terminal. From the formula below, we can calculate by subtracting negative 2.38V from positive 0.34V to form 2.72V as the cell voltage value.
For question number 2, diagram 6 shows the apparatus set up to study the corrosion of metal. What can be observed in test tube P and test tube Q after a few days? Iron in test tube P will turn green first and slowly become brown and corrode, while copper in test tube Q will corrode after a few days.
Number 3. For the cell notation on the anode side, I use magnesium instead of zinc because magnesium is more reactive than zinc. And for the cathode side, I use copper. Number 4. The balanced chemical equation for the reaction is CuO plus H2 produce Cu plus H2O. The explanation is the oxidation number in copper oxide is decreased when reduced by hydrogen gas. The reducing agent in the redox reaction is hydrogen gas, while the oxidizing agent is copper oxide.
Question 5. Combustion is an exothermic reaction, so the energy diagram shows that the reactant is C2H5OH plus 3O2 and the product form is 2CO2 plus 3H2O. And the temperature of surrounding will be raised because heat energy is released.
For question 6, 1 Roman, we need to find the number of moles of propanol and the temperature change during the reaction. We knew that propanol is a compound with formula of C3H7OH and the mass of propanol for the reaction is 2.16 gram. First of all, we need to find the molar mass of propanol that total up to 60 gram per mole. By using formula number of moles equal to mass divided by molar mass, we can find the number of mole of propanol is 0.063 mole. For the temperature change, we need to identify the heat energy of the reaction with formula delta H equal to plus minus Q divided by N kilojoule per mole. From the formula, we can find Q by multiplying number of mole with delta H that gives out heat energy of 73.08 kilojoule and convert it to joule that makes it 73,080 joule. By using Q equal to mc theta, we can get the temperature change of 87.0 degrees Celsius.
For 7A1, V is hydrochloric acid and W is nitric acid. For 7A2, the difference is hydrochloric acid has higher value than nitric acid because hydrochloric acid ionizes more hydrogen ion than nitric acid.
For question 7b, calculate the change in temperature of the mixture in set 1. It is given the specific heat capacity is 4.2 joule gram -1 Celsius -1. So based on the table, you should put all of the information into the formula of number of moles equals to mv over 1000 to find out the number of moles. So you will get 0.1 mole. Once you get the number of moles, you can proceed to find the heat change, which is number of moles times heat of reaction. So heat change equals to 0.1 mole times 57 kilojoule. You will get 5.7 kilojoule. But you have to change the heat change unit into joule. This is because the unit of heat change, mc theta, is normally written in joule and not in kilojoule. 1 kilojoule is equals to 1000 joule. After you multiply with 1000, you will get 5700 joule. So you will use heat change equals to mc theta, and you make theta as a subject, and you should change the 100 cm cube into gram. So that is y times with 1 gram cm cube. And you should just use your calculator to calculate the theta, and you will get 13.57 Celsius.
Question 7. Procedure. By using a measuring cylinder, 50 cm cube of 2 mol Dm negative cube potassium hydroxide KOH solution is measured and poured into a polystyrene cup. 2. Thermometer is placed into the potassium hydroxide KOH solution and the initial temperature is recorded. 3. By using another measuring cylinder, 50 cm cube of 2 mol DM negative cube hydrochloric acid HCl is measured and its initial temperature is measured with a different thermometer. 4. The hydrochloric acid HCl is quickly poured into the polystyrene cup containing the potassium hydroxide KOH solution. The mixture is stirred with the thermometer and the highest temperature achieved is measured. Thermochemical equation: H plus OH negative equals to H2O with heat of reaction of negative 57 kJ mol negative 1. The energy level diagram shows that H plus OH negative is the reactant while H2O is the product, and negative 57 kJ mol negative 1 as the heat of reaction.
Next, question number 8. Polyvinyl chloride PVC is a synthetic polymer. It can be used to make water pipes. A. 1 Roman. What is meant by polymer? Polymer is a substance made out of a large number of monomers, which is small molecule that link together to form a larger molecule. A. 2 Roman. The monomer for PVC is chloroethene. Draw a structural formula of PVC and chloroethene. For A3 Roman, explain how PVC can cause environmental pollution and suggest on ways to solve this problem. First point, PVC is not biodegradable or degradable. Items made from PVC will retain their form for decades and will simply turn into smaller pieces of plastic. Animals can ingest these pieces and thus will block their digestive tracts. Second point, phthalates are added to PVC and act as flexibility agent of PVC. These chemicals may cause cancer, kidney and reproductive system damage. The disturbing part is that soft PVC is often used in toys for young children and they will just simply put their toys in their mouth and will bring concern to their parents. There are some ways to solve this problem. First, avoid buying PVC products whenever possible and reduce your overall plastic use. Lastly, contact companies or do some research about what the product made of and demand for PVC-free alternatives.
Now we move to question 9b, 1 Roman. State the part of the detergent particles that is soluble in grease. The part of detergent particle that is soluble in grease is the hydrophobic part. For question 9 to Roman, based on the above figure, explain the washing action of detergent particles on grease stain. Detergent's ion will help to reduce the water surface tension. The hydrophilic part will dissolve in water while the hydrophobic part dissolves in grease stain. Mechanical agitation helps to put away the grease from the shade and break the grease into small pieces. For question 9, 3 Roman, the complete figure is as above. Mechanical agitation or stirring of water during scrubbing will help to put away the grease from the fabric and break the grease into small droplets. The repulsion force between the negative charge on the surface of greasy droplets prevent the droplets from coagulating or redeposit to the fabric. This will hold the droplets and make them remain suspended in water, forming an emulsion. Question 10. State 2 methods of food preservation which use in our daily lives and explain how the methods work. 2 steps that helps to preserve food are freezing and fermentation. Freezing is one of the steps to preserve foods. In general, low temperature reduces the growth rates of microorganisms and slow many of the physical and chemical reactions that occurs in food. Fermentation increases acid or alcohol content and decreases water activity. All microorganisms have basic requirements for life. They cannot tolerate harsh environments such as those with low pH, high alcohol content or high salinity.